Everyone, welcome to this tutorial on how to use eQTL catalog visualization tool. Today we will explore how to investigate a genetic variant RS10774671. We start by heading over to Open Target Genetics, where we will search for the variant. If we will scroll down, here we can see that this variant is associated with both COVID-19 severity and infection, and as well as with lupus, an autoimmune disease. We want to explore how this variant affects the diseases. For that, next we will transition to eQTL Catalogue Browser to dive deeper into the molecular consequences of this variant. Here, we copy the variant RSID to the search bar. We select RSID from select field. We can either press enter or query a subset. Once the results load, sort the data by the p-value. This helps to identify the most significant associations related to the variant. We can observe a strong association in the whole blood with a TX revised transcript level QTL for the OAS1 gene. If we scroll down here, we can see that this is the most strongly associated transcript. It's also highlighted with a lighter blue. If we will click on it, we can see the corresponding box plot. While these results give us some useful insights, they can be a little bit tricky to interpret. And if we suspect there's some splicing signal over this intron, we can look further using leaf cutter signals. If we look into the first leaf cutter signal on the table, we can see that it happens to be in the GTX adipose tissue. Here, we can see that this splice junction has the strongest association with this variant. If we click on it, in the box plot, we observe that the usage of this splice junction decreases with each alternative allele of this variant. We can also see the same effect on the read coverage plot. In the reference allele carriers shown in red, this intron is completely spliced out, whereas in the alternative allele carriers shown in light and dark blue, it is not. We can also explore other splice junctions. For example, the usage of this splice junction increases. Here also, the usage of this splice junction increases as well. You can also see where these junctions are located on the read coverage plot by looking at the vertical lines. To see the cell type and tissues in which the splicing event is detected, we can filter by the leaf cutter quantification method and view all leaf cutter QTLs. Sorting by fine mapping posterior inclusion probability, PIP, helps to identify the most likely causal variant. PIP is a probability between 0 and 1, where 1 means that the variant is likely to be a causal variant. So here we see that this variant has PIP1 across multiple data sets for the same gene, further indicating that it's likely to be a causal variant. Finally, let's confirm these findings using Splice AI browser. We copy this variant, go to Splice AI browser. Here we need to replace underscore with a hyphen. We submit. And Splice AI confirms that this is splice acceptor variant with a significant effect on splicing. In this tutorial, we've demonstrated how to use eQTL catalog visualization tool to investigate a genetic variant and its potential impact on splicing. We explore how to filter and sort data for better insights and use additional tools like Splice AI to verify our findings. Thank you for following along. Goodbye.